Hello, welcome to this lecture video. So I'm teacher Melai and let's talk about multiple linear regression. Okay, so let us consider this. The business objective facing the marketing manager of the Omni Foods is to develop a model to predict monthly sales volume per store of Omni Power bars and to determine what variables influence sales. So this is our problem. And we have two independent variables that will be considered in this problem. The first one is the price of an OmniPower bar as measured in cents and the monthly budget for in-store promotional expenditures. So measured in dollars in-store promotional expenditures typically include signs and displays, in-store coupons, and free samples. And the dependent variable y is the number of the Omni Power bars sold in a month. So data are collected from a sample of 34 stores in a supermarket chain selected for a test market study of the Omni Power. So all the stores selected have approximately the same monthly sales volume. So this is our data. So we have the following variables. So we have, of course, the stores. We have store 1 to store 34, which corresponds to respondent. And then for our sales, so we have the following sales, the following price, and the following promotion. So as I mentioned in our previous slide, so what is our dependent variable here? Our dependent variable is the sales, while our independent variable is price and promotion. Since we have more than one independent variable that we want to explore, then it is not enough to use the simple linear regression because in simple linear regression, we need to consider only one variable. So in this example, it means that since it's two independent variables, we are going to use the multiple linear regression. So again, an assumption that this follows a linear relationship. In our simple linear relation, or rather simple linear regression, we use the scattered plot for us to visualize our data. So here, if it is possible for us to make use of some softwares or some online graphing softwares that can produce 3D scatter plot, then well and good. So just like in this example, we have the 3D scatter plot of sales versus price versus promotion. And what is the multiple regression model with k independent variables? So this is the formula. So we have y sub I is equal to v sub 0 plus v sub 1 x sub I, x sub 1 I plus v sub 2. Or actually this is the beta, beta sub 2 x sub 2 I plus beta sub 3 x sub 3 I plus until of course to the last variable v sub x sub ki. So we can actually have a lot of or more than 2, 3, 4, 5 or more independent variables or k independent variables. So our b sub 0 is our y-intercept. B sub 1 is the slope of the y with variable x sub 1, holding of course all variables x sub 2, x sub 3, and all other variables constant. And for b sub 2, so the same case, this is the slope. So our b sub 0, b sub 1, b sub 2, b sub 3, b sub until b sub k are actually our, or rather, are the slopes of the y variable corresponding with its corresponding variable x. So in general, b sub k is the slope of y with the variable x sub k holding variables x sub 1 until x sub 2, x sub 3, to x sub k minus 1 constant. And just like in our simple linear regression, we also have our e sub I, the random error in y for observation I. So this is the multiple regression model if we only have two independent variables. So we have y sub y is equal to b sub or beta sub 0 plus beta sub I x sub 1 I plus beta sub 2 x sub 2 I plus e sub I. So b sub beta sub 0 is the y-intercept, beta sub 1 is the slope of y with variable x sub 1 holding variable x sub 2 constant. Beta sub 2 is the slope of y with variable x sub 2 holding variables x sub 1 constant. And of course, e sub I is the random error in y for observation I. So we have another term. So we have what we call the net regression coefficients. So they estimate the predicted change in y per unit change in a particular x, holding constant the effect of the other x variables. Okay, so in predicting the dependent variable y, you can use the multiple regression equation to predict the values of the dependent variable. So for example, what are the predicted sales for the store charging 79 cents during a month in which promotional expenditures are $400? So you can actually predict for the value. But if you still remember, in our discussion for simple linear regression, we have the interpolation and the extrapolation, wherein the value of x must be is still within the range of our is still within the range of the data that we use to craft or to come up with the simple linear model. So this is also the same in the case of our multiple linear regression. So the value of our x must be within the range of the values that we used. So we have the coefficient of multiple determination. So the coefficient of multiple determination is equal to the regression sum of squares divided by the total sum of squares. So it is actually the same with our simple linear regression. So the r squared is the same r squared also in our coefficient of determination in the simple linear regression. So, however, we have to consider that when we are using multiple linear regression, adjusted R squared are also generated. And to take into account both the numbers of the independent variables in the model and the sample size. So reporting the adjusted is extremely important when we are comparing two or more regression models that predict the same dependent variable but have a different number of independent variables. So in a simple linear regression, we are suggesting that what you need to report is the R squared. But for a multiple linear regression, since we have two or more variables, it's actually better to report the adjusted R squared. So this is the formula of our adjusted R squared. So where K is the number of independent variables in the regression equation. So it actually needs the value of R squared, the computed R squared for you to come up with the adjusted R squared. So what else do we need to consider here? So the test for significance of the overall multiple regression model. So overall, F test to determine whether there is a significant relationship between the dependent variable and the entire set of the independent variables. So it is the overall multiple regression model because there is more than one independent variable. So you use the following null and alternative hypothesis. So just like our simple linear regression, our HO still states that there is no linear relationship, but of course with independent variables, it's with letter S. So it's between the dependent variable and independent variables, or similar to beta sub 1 is equal to beta sub 2 is equal to until to beta sub k, which is equal to 0, because there's no linear relationship if the value is equal to 0. And in alternative, which is our h sub 1, at least 1 b sub j is not equal to 0, where j is equal to 1, 2 until k. Or in other words, we are simply saying that there is a linear relationship between the dependent variable, or and rather at least one of the independent variables. So not necessarily that all the independent variables. So this is the formula for our overall F stat if you will use, of course, our manual computation. So what is the MSR? It is the regression mean square. MSE is the mean square error. So for our other data that we can also generate using the Microsoft Excel, it can also give us this value. So we can find this values once we generate the result for the result using Microsoft Excel or other softwares like the SPSS. So inferences concerning the population regression coefficient. So for the test of hypothesis, this is testing for the slope in multiple regression. So we also, again, as mentioned also for F test, we also obtain the value of t test when we are generating our multiple regression model. So here, b sub j is the slope of the variable, j with y holding constant effect of all other independent variables. S sub b sub j is the standard error of regression coefficient b sub j. That is of course our test statistic. K is the number of independent variables. And b sub j is the hypothesized value of the population slope for variable j, holding again constant effect of all other independent variables. So for the confidence interval estimation, so this is the formula. B sub j is plus minus the test statistics divided by 2 critical value corresponding to the upper tail of alpha over 2 multiplied by S sub B sub J. However, as mentioned, we are not going to consider the manual computation. We are going to use the Microsoft Excel in generating, or if not, we will use the online calculator for us to generate the values. Okay, so in the next video, we are going to answer our problem, the posted problem here about the Omni company. Thank you for watching.